Okay,
Thank you.
okay, you're welcome. Okay, welcome, dear students, to the class. So today we have these topics that we will be covering, and this is a chemistry class. So the first topic that we will be covering is a matter. We will discuss what matter is, how many different types do we have, and how do we classify, and some of the properties of matter. Then we will talk about weighing in. How do we weigh substances or matter? What is actually weight? And the third topic is types of matter. As I just said, we will classify matter into different subclasses. And then we will discuss the characteristics of matter, combinations of matter, and concentration and density. So these are some of the topics of our today's lecture that we will be covering. So let us start from matter. So as you guys must have read before, that matter has anything that has mass and it occupies space. So what do we mean by that, that matter has anything that has mass and it occupies space? It is because matter is something which will always have a certain length, a certain width, and a certain height, and it will occupy space. It will occupy some area, right? For example, you are a matter. We are made up of matter, right? So we have a weight, we have a height, we have a width, right? And we occupy some area. Or for example, the sofa or the chair that you are sitting in right now. So that is also a type of a matter, and it has a weight, it has a volume, and it is occupying some area, right? So all those things which have some mass and they occupy some area. So that is basically what a matter is. So matter exists in various forms and states around us. For example, we have liquids, we have gases, we have solids. So we observe matter in three different states, right? So if you are drinking water, so that is liquid. That is also a matter. For example, you are dealing with ice, you are breaking ice, or you are putting ice in the glass of water. So that is matter in solid state. And the air that we are breathing right now, so that is basically matter as a gas. So we have three main states of matter. In fact, four. The fourth one is plasma. And a good example would be a fire or the state of the sun, right? So in sun, we have another state of matter, which we call plasma, in which the atoms are in ionic form. Yeah, just like that. So matter is made up of atoms. So this point is very, very important and fundamental to the concept of science, that everything is made up of atoms. So matter is made up of atoms. So you and I, we are made up of atoms, right? So which are the building blocks of matter? So different types of atoms, they combine together, and they form molecules and they form compounds. And same types of elements or atoms, they can also combine together and they can give rise to matter. So this is what matter is. Now let us move forward and let us know more about matter. Okay, so now as you can see here on this slide, that we are about to learn the kinetic matter, what actually a matter is with respect to the kinetic model of matter. So let us talk about the kinetic model of matter, or what is a kinetic model. Kinetic model actually means that uh, everything in this universe is made up of particles, and these particles, they may have higher energy or they may have a lower energy. So this is basically what a kinetic model is. So it explains with the help of this kinetic model, we can explain different concepts. So solids, if we want to explain solids with respect to kinetic model of matter, we would say that solids have strong attractive forces between atoms. So whenever we are dealing with a solid, the attractive forces between the atoms of solids, they are very strong, or molecules, and they have very low kinetic energy. So what is kinetic energy? It is an energy due to motion, right? So would anyone like to tell me what's the formula or what's the equation for the kinetic energy? How do we calculate it? Anyone? Darla, Eliani, or Janet, Adrian? So what is the equation for kinetic energy? You can unmute and answer the question, or you can type.
Good morning, guys.
Good morning.
Darla, Eliani, Janet. Are you the question for the teacher? It's okay.
Yeah, let me repeat the question. Yeah, but it's all right. Let me explain it to you guys. You can write it down. You can note it down. I hope you guys will have notebooks and pencils in your hand. So kinetic energy is equal to half times mv square. Okay, so we multiply mass with the velocity square, and that equals kinetic energy. So what it tells us basically that kinetic energy is energy due to motion. Whenever something is moving, it will have a kinetic energy. So am I moving right now? No. So do I have kinetic energy? No, not that much, right? So when you are running, when you are moving, when you are going from one point to another point, so that is when you have kinetic energy, right? So solid molecules, they have a very low kinetic energy. Why? Because they are not moving, they do not move, okay? So liquids, on the other hand, they also have very strong attractive forces between the atoms. For example, water, aqua, or aqua H2O, right? In Spanish, we call it aqua. So water molecules have intermolecular forces between the molecules. So all the water molecules, they are tightly packed. They are closely packed together. So kinetic energy, we have some kinetic energy, and it is higher as compared to the kinetic energy in solids. In solids, the atoms, they cannot move at all. But in liquids, we see some motion, and that is why molecules in liquids, they have some kinetic energy, right? And in gases, so what happens in gases? Gas molecules are, very energetic, and they are moving here and there. So for example, if you have a perfume, and if you spray it in one corner of the room, so what will happen? So after a few seconds, or within a minute, a person on the other side of the room would be able to smell that perfume. So what happened? So the gas molecules from that perfume, they traveled from one corner to another corner of the room, right? So the gas molecules, they have movement, and they have lots of movement. So that is why we say that gas molecules, they have very high kinetic energy. So I hope the point is clear. When molecules, they are moving, they have kinetic energy, and when molecules do not move, so they do not have any kinetic energy. And when something is not moving, so it has a potential energy, right? So these are the two types of energies that we usually see from time to time, and we see a lot in physics and chemistry and in science in general. So you should know about these two types of energies that we deal with. Kinetic energy, it is energy due to motion, and a potential energy. Potential energy is the energy which is at rest. When you are at rest, you will have a kinetic energy. Yeah. So if you have any questions, please do not hesitate. Just unmute your mic and ask the question. Okay. You can raise your hand and you can ask the question. I would like you guys to participate in the class. So I want to make it interactive, right? Okay. So this is the pictures of solid molecules and liquid molecules and gas molecules. So you can see here in the first picture where I have explained or I have shown the molecules or the atoms of solids, and solid is a state of matter. And as you can see that these are tightly packed, there is very little space between them. They cannot move, right? So this atom or this molecule, it cannot move because it is surrounded by other atoms. So it does not have enough space where it will move, right? So that is why solids, they will not have any kinetic energy. Why? Because the molecules in solids, they cannot move, right? So now in liquid, what happens is that the liquid, you can see that we have some space as compared to solids within these molecules. And that is why liquids have a higher kinetic energy as compared to solids. So remember, solids have a very high potential energy. Yes, Adrian, you have a question, please ask.
Good morning. Now, sorry, I have a question. In that case of liquids, it depends the type of liquid to the kinetic energy, or it doesn't matter?
That's an excellent question. We have different types of liquids. Yes, technically it affects, but the effect is very negligible, okay? So what actually matters is the temperature. So for example, if you have a liquid on 25 degrees Celsius or at room temperature, so you will have a different kinetic energy. But if you raise the temperature of that liquid, right? So the molecules will absorb heat energy and they will become more energetic. So with heat, with temperature, the kinetic energy of the liquid molecules, it increases. But at the same temperature, most of the liquids, they have negligible difference between the kinetic energies. Is it clear?
Yeah, thank you.
Okay, you're welcome. Excellent question. So now look at gases. So in gases, we have lots of space, and you can see that we have a random motion in the gas molecules. So this is called a Brownian motion. Okay, you can note it down. So the gas molecules, they have vibrational motion. Okay, and they have different types of motions that molecules exhibit. So in gases, the potential energy would be minimum. It will be very low, and the kinetic energy will be very high. And kinetic energy is directly proportional to the temperature. And it is true for all these three states. If you give temperature to solids, what will happen? They will absorb that energy and they will start vibrating more and more, and the solid molecules, they will collapse and they will change into liquid. And when liquid will absorb kinetic energy, it will eventually change into a gas. So you can take an example of ice as a solid. So when you heat it up, when the ice absorbs temperature, it melts. See? So why it melted? Because it achieved a higher kinetic energy. And if you heat water, liquid, up to 100 degrees Celsius, so what will happen? The molecules will absorb more kinetic energy and they will be changed into a gas. So this is basically what a kinetic model of matter is. Okay, so I hope this point is clear, and let's move on. Yeah, so some more properties of solids, liquids, and gases. So as you can see, solids, they are rigid. What do I mean by rigid? So I have a pen with me here, and what is happening with this pen? If I want to press it, okay, if I want to press it, I cannot press it, you know. Why? If I want to bend it, I cannot bend it. Why? Because there is no space between the atoms, between the molecules. So that is why solids, they are rigid. We cannot compress them, okay? When I say something is rigid, it means that it cannot be compressed. So solids are rigid, they have a fixed shape. If you look at this pen again, it has a fixed shape. I cannot change it, I cannot mold it. So it has a fixed volume and it cannot be squashed. As I said, that you cannot compress it. So these are some of the properties that matter exhibits in its liquid state. In a solid state, I'm sorry. So now let's move on to liquid. So what happens with the liquid? So liquid is not rigid. For example, if you have a glass of water and you pour one glass into another, so the liquid will take the shape of a container, right? And if you have a bucket and if you transfer that glass of water to the bucket, so the water will shape of that bucket, right? So that is why we say that the liquid molecules, they are not rigid. Why? Because they have some space in between them. They can slide on each other. That is why they can change shape. So no fixed shape and no fixed volume. Sorry, they have a fixed volume and cannot be compressed. Okay, so no fixed shape, but volume, it is fixed. What is volume? Anyone? Do you have any idea what volume is? Volume is basically what volume is basically, you know, you multiply height and well, you multiply width and you multiply length. So these three things, you know, you get an area. So it's something like that. So what is density? Density is mass divided by volume. And volume is when you multiply density into mass, you will get the volume, right? So this is how we exhibit volume. So let us talk about gas now. So gases have no specific shape and no fixed volume. You can, you know, some molecules of gas can take up the entire room, and the room of the entire the air in the entire room, it can be compressed into a small cylinder. The room you are sitting in right now, or the room that I'm sitting in, the air that it contains at the moment, all this air can be compressed into a small cylinder. Okay, so that is why we say that gases, they do not have a fixed volume. I hope this is clear. Yes, is there any question, Adrian or Darla? Eliani, is it clear?
Yes.
Okay, okay, thanks. So let us move to the next slide now. So now let us talk about weighing in, okay? What is weight? If anyone would like to answer, what is weight? Or what's the difference between weight and mass? Okay, let me explain. So, or if you guys know, you can type in the comments. So weight is a measure of the force exerted on an object due to gravity. Okay, what is gravity? Gravity is a force that attracts us towards the center of the earth. Okay, so in this universe or in this planet, two things, they attract each other. Okay, for example, I have this pen, and for example, I have this perfume bottle. So what is happening if I hold them together like this? So they are attracting each other, right? So there is an attraction between these two objects. So similarly, the Earth also has a gravity, and it pulls us down towards itself. So the the force or the measure, okay? So when we want to calculate it, that how much the gravity is pulling us down, so that is weight. So scales and are instruments used to measure weight, and they come in various types and sizes. So the unit of measurement for weight is newtons or pounds, and accurate weighing is crucial in many applications such as cooking, chemistry, and manufacturing. You need to know the weight of the substance. Okay, for example, you're baking a pizza, and so you should know the amount of the cheese that you want to put on your pizza, or the amount of sweet pepper, or if you like pepperoni, right? So all these ingredients, you have to measure them and before you can use them, right? So this is how weight is important. And another thing about weight is that a weight can change depending on the gravity. So for example, here I am on the Earth. Let's suppose I have a weight of 70 kilograms. Okay, so if I go to the moon, which has a lower gravity, which has a lesser gravity than Earth, so my weight will be less. I will weigh less. Why? Because a lesser force is acting on me, which is trying to pull me to the center of the Earth. Okay, so my weight will reduce on the moon. But what will happen if I go to the sun? Apart from burning, of course. So sun has a very high gravity. So my weight will be very high. So this is what basically a weight is. I hope you are getting my point. There is a difference between mass and weight. So always remember, mass will remain the same, right? Your weight can change depending on the gravity, and your mass will remain the same. If you are on the Earth, you will have a certain weight. If you go to the moon, your weight will decrease because the decrease in the gravity. Okay, and if you move to the sun, your weight will increase. Why? Because sun has a higher gravity than the Earth. So these are some of the apparatuses that we use, or instruments to measure weight. So this is a digital balance. This is a spring balance. This is a traditional rod balance. This is again a spring balance, and this is another example of a spring balance, right? So these are some of the instruments that are used to measure weight. So as I just said, the common instruments that we use to measure weight, these are spring scales, balance scales, and electronic scales. So this one is an electronic scale. You can see that it is digital. So these scales, these are used in laboratories, and so that we can exactly know that how much amount we are weighing. Okay. So digital scales are more accurate and precise than the traditional scales. So precision refers to the degree of consistency in repeated measurements, while accuracy refers to the closeness of an instrument to the true value. Okay, for example, you have a sample and you weigh it one time and it will give you, let's suppose, 5 grams. And then you take it back and then you again measure it. So it should give you 5 grams again, right? So this is what accuracy or a precision is, right? So so these things are very important. And why these are important, let me give you an example. For example, you have a headache and you want to take aspirin. So the tablet that you are going to take for your headache, it should contain a precise amount of the drug. Okay, so if that drug in your tablet is increased, so you may get a side effect, right? So it may not be safe to consume. So this is why it is very important that we should measure things accurately. Or for example, when you go to the tailor, you want him to make a shirt for you or make a pants for you, so he has to measure you, right? So he has to take the measurements, and those measurements should be correct. So if he makes a mistake in those measurements, then you may not have the right fit for the dress that you will be wearing. So this is how, or this is why measuring is important in different aspects of our lives. So now, types of matter. So types of matter, it can be classified into pure substances or mixtures. Before that, we discussed the states of matter, right? And we studied 3 states of matter. Number 1, solid. Number 2, liquid. And number 3, gases. But types of matter, they are different than the states of matter. So do not get confused between these two concepts. So types of matter, we have pure substances, or we have impure substances, which are also called mixtures. So what is a pure substance? A pure substance are made up of only one type of atom or molecule, while mixtures or impure substances, they are made up of 2 or more substances physically combined. Can anyone give me an example of a mixture? This should be easy. Yes, please.
Water.
Okay. Water. Would you like to try again? Water is basically, it's a pure substance, right? Why it's a pure substance? That in a glass of water, you have all the molecules of water. What's the formula for water? It's H2O. So when you are drinking water, so you have H2O molecules in it, where hydrogen and oxygen are chemically combined. You cannot separate water, okay? So you cannot split hydrogen and oxygen from water that easily. So water is a pure substance. So what would be an example of a mixture? Yes? Okay, a soda. So a soda is an example of a mixture which is impure, right? So what is a soda actually? Soda is water, soda is sugar. When you mix sugar into water and when you put some gas in it, right? When you put some color in it, it will turn brown for a Coca-Cola or a Pepsi. So that is now an impure substance, right? It is not pure anymore. Why? Because it does not contain the same things. Adrian is saying that maybe a bread dough. Yeah, that's right. That's a mixture. That's an impure substance. Why? Because in a bread dough, we have like carbohydrates and we have different types of complex molecules. So that can be labeled as a mixture. So that's correct. Or simply when you mix sand in water, right? You or sugar in water. So these are mixtures. And when you have simple water, that is a pure substance. So I hope the point is clear now. So let's move on. So pure substances can be further classified as elements or compounds. So water is a compound. That is why it is a pure substance. Okay, so this is an excellent explanation here for the types of matter. And if you can see here, we have matter, liquid, gas, solid. So it can be divided into pure substance and a mixture, which is an impure substance. Mixture can be separated easily. You can separate things from a mixture very easily. And there is no chemical reaction in a mixture. But in pure substances, you cannot separate things that easily. Okay, I hope you guys are taking notes as I'm explaining these concepts to you. So a pure substance, it cannot be separated. You cannot separate water. You can separate sugar or water. You can separate sand from water. How would you separate sand from water, Adrian or Darla? How would you separate sand from water?
Sorry, can you repeat?
I said, how would you separate sand from water? You have a mixture of sand and water. So how would you separate these two? You must have heard of the concept filtration, right? You filter it. You can take a piece of paper or a cloth, and you can cover one glass, and you can transfer the other glass, which contains water and sand. So the sand will remain on the top of the cloth, and the water will be filtered from that cloth into the glass. So this is how you can separate it. So this is a mixture, okay? So pure substances are further classified into element and compound. Elements, for example, we have hydrogen, the entire periodic table. Elements, hydrogen, iron, helium, sodium, gold, copper. So all these are elements, and these are pure substances. What is an element? An element is a substance which is made up of the same atoms. And what is a compound? A compound is a substance which is made up of two or more atoms. For example, water. Water is a compound. It is not an element. Why? Because it is made up of two different types of atoms. We have hydrogen in it, and we have oxygen in it. We have two atoms of hydrogen in water, and we have one atom of oxygen in water. So this is why it is a compound. And oxygen and hydrogen, they are chemically combined together. You cannot separate them easily. So now let's talk about the further classification of impure substances, which are mixtures. We have two types of mixtures. We have homogeneous mixtures, and we have heterogeneous mixtures. So what are homogeneous mixtures? Homogeneous mixtures are those type of mixtures where you have uniformity, okay? When something is spread out evenly. But in heterogeneous mixture, the solution is not a uniform, okay? What do we mean by uniform? Let me show you with the help of this example. Okay, so this cup of coffee is a homogeneous mixture. Why? Because all the contents of the coffee are distributed evenly, okay? So this is a homogeneous mixture, and this is a heterogeneous mixture. And this is a cereal in milk, and it is representing a heterogeneous mixture. Why? Because most of you guys would eat cereal for breakfast in your daily routine. So what happens is that when you take one spoon, you may have 3 flakes and 1 strawberry. And when you will take another spoon, you may have 0 strawberries at all, or you may not have any strawberry on your spoon, right? So it means that this type of mixture is not even, okay? The contents in this bowl They are not evenly distributed. Yes, Anahi, you raised your hand. You want to ask a question? Please ask.
Can you please repeat the concept of coffee, please?
You want me to repeat it?
Yes.
Okay. Coffee is a homogeneous mixture. And why a coffee is a homogeneous mixture? Because the coffee and milk molecules, they are evenly distributed, right? So you cannot tell where coffee molecules are or where the milk molecules are, right? So this is a homogeneous mixture. For example, when you dissolve sugar in water, so what will happen to that sugar? It will disappear and it will disperse evenly in the water. For example, if you take a sip, just one drop of water, it will be sweet. So it means that now sugar is everywhere in that solution. I hope you're getting it. Did you get it? Is it clear now, Anahi?
Yes.
Okay, that's good. So heterogeneous mixture, as I was explaining, that it is not evenly distributed. What will be another example of heterogeneous mixture? Anyone? Can you guys give me another example of a heterogeneous mixture?
Yeah, it could be the pizza. I don't know.
Yeah, excellent. Yes, yes, you are 100% right. That's very good. Pizza. Why? Because the topping is not evenly distributed. In one bite, you may have an olive or you may have a mushroom, and in another bite, you may have a pepperoni or something else, or maybe a pineapple if you like it on your pizza. So you see, the topping is not evenly distributed. So I'm very happy that you got the concept. Okay, so I guess we can move forward. So so now characteristics of matter. So I hope you guys are learning these things for the first time, right? Is this thing new for you?
Actually, for me, not.
Okay, but you're studying something, right? You are gaining something.
Yeah, a bit. I think it's a
Okay.
review. I
Maybe in the
don't
next few
remember.
slides, you may find something new.
Yeah.
Okay, so characteristics of matter. So what are characteristics of matter? Physical properties. These can be observed without changing the identity of the substance, right? So they a color, shape, texture, order, and density. So physical properties can be observed and measured using various tools and techniques. A color, shape, texture, and odor are examples of sensory physical properties. We can sense them. And density is a measure of the amount of the matter in a given volume when boiling point is the temperature, while boiling point is the temperature at which substance changes from a liquid to gas. And what is a conductivity? Conductivity refers to materials' ability to conduct electricity, while magnetism refers to materials' ability to be attracted to a magnet. Okay, so these are some of the characteristics. We have physical properties, we have chemical properties of matters. So what are the chemical properties of matter? Chemical properties are characteristics of matter that can only be observed by changing the identity of the substance. For example, it includes reactivity or heat. When matter, it reacts with something else, it will change, okay? So chemical properties involve the ability of a substance to undergo chemical reactions or transformations. So chemical reactions involve the rearrangement of atoms to form new substances with different properties. So matter can combine, okay, one type of matter can combine with another type of matter. So matter can interact with each other. So two different types of matters, they can interact. A solid can react with a gas, or a gas can react with a gas. right? Or a liquid can react with a solid, or a solid can react with a solid, and it can make new things. So this is basically, these are the chemical properties of matter, where the matter is changed. It is changed from one thing to another. It may change its composition, or it may change its state. So both of the, or maybe both. So these are basically the chemical properties that we see with matter. So identifying chemical properties require performing experiments or observations that can result in a chemical change. Okay, so for example, what is a physical property? I have this matter, and what's the color of it? So this is a physical property. It has a red color, right? So this pen, it has a red color, and this is a physical property. So what is its length? If I want to measure from this point to this point, so it will have a certain length, right? So it will have some length. So this is a physical property. So now volume. So how much volume is being occupied this pen? So this is again a physical property. Opacity. What is opacity, Adrian? Do you know?
Yeah, if is the object, sorry, it's transparent or less transparent. This is the opacity.
Yeah,
Sorry, my English.
you have the concept. Yeah. So opacity is the property of the object, and we define it that how much light can pass through it. So an object can be opaque if no light can pass through it, right? So this pen, it is opaque, right? I cannot see. If I hold it in front of my nose, so a part of my nose you cannot see. Why? Because the light cannot pass through this pen. So this is opaque. So this is also a physical property, okay? So now, acidity is a chemical property, reactivity, that how will it burn if I want to burn it, if I want to heat it, right? So what will be the composition of this pen? What will happen to this pen if I heat it, right? So when you heat things, they change chemically, and a chemical change is not reversible. For example, I have this piece of paper, okay? If I have this piece of paper and I burn it, so can I change it back to a paper from ashes? No, right? So chemical change is irreversible, and a physical change is reversible. So flammability, toxicity. What is a toxicity? Toxicity means that how dangerous a matter is to human beings or to living organisms and to the environment, right? So normally nowadays we say that this plastic, it is toxic. It takes a lot of time to change. So it is causing lots of problem. So we should not have things made out of plastic, right? Or for example, a highly flammable gas, for example, petrol. So if you have a gasoline somewhere in a bottle, so you have to take care of it, because it can catch fire. So this is also a toxicity or flammability. So toxicity is basically when we consume things, when we eat them, right? So for example, if you eat bad food, so what will happen? You will get sick. So we will say that this is a chemical property, that things can make you sick, right? So matter, it can have physical properties, and it can have all these chemical properties. What about acidity? How would you define acidity? Anyone? What is acidic, or what is basic? Do you guys have any idea? We have 12 minutes left. Okay, let me explain. So acidity is something when something tastes sour, For example, lemon or oranges. So they have a sour taste. And why do they have a sour taste? They are acidic. And why are they acidic? They are acidic because they have a higher concentration of hydrogen ions in them. So if something is acidic, we would say that it has a greater concentration, a greater amount of hydrogen in it. So why the lemon, it is acidic? Because lemon juice contains lots of hydrogen dissolved in it. I hope this is clear. And the opposite of acidic is basic. So what is basic? When something have a low concentration of hydrogen, or if something has a greater concentration of the hydroxyl ion, OH minus. So that is a base actually. It is basic, right? So this was about acid and base. So now let us talk about our next slide. So chemical change. What is a chemical change? Iron rusting, burning wood, metabolism. When you eat something, it gets broken into substances that it changes in our body. When you eat fruits, right, they get changed in our body. Cooking an egg. Once you cook an egg, you cannot take it back to that slimy form, right? It's permanent. You cannot change it back. Baking a cake or making a pizza, once your cake is ready, you cannot change it back to the dough, right? So electroplating is a process where metals, they are coated or they are polished. Your cell phones, your laptops, this is electroplating. Okay, a rotting banana or a rotten banana. What is a rotting banana? A spoiled banana. So once fruits, they start to spoil, you cannot change them back, right? So all these are examples of a chemical change. So vinegar and baking soda, fireworks, and a chemical battery. The battery in your cell phone, it is also running on a chemical reaction or a chemical change. Okay, so let's move towards our next topic. So combination of matters. So chemical reactions involve the combination, rearrangement, or separation of atoms to form new substances. So reactants are the starting substances in a chemical reaction, while products are the substances formed as a result of the reaction. So balancing chemical equations is essential to ensure that the number of atoms on both sides are equal. So this is important, right? So on the left-hand side, we have reactants, and on the right-hand side, we have products. So if you'd like to balance it, so for example, if you have this equation, on one hand side, on the left-hand side, we have the reactants, and on the other side, we have the products. So what will happen? Can you tell me how many hydrogen atoms or how many total atoms do we have on the left-hand side? Anyone? How many, what is the total number of atoms on the left-hand side? Can anyone explain? Okay, let me tell you. So how would you balance a chemical equation? You have to write down that how many atoms do you have on the left-hand side, right? So we have 3 carbons, we have 8 hydrogens, and we have 2 oxygens. You can write it down. And on the right-hand side, we have 2 hydrogens, and we have 3 oxygens. This is 2, so these are 2 oxygens, and this is 1 oxygen. So 2 plus 1, we have 3 oxygens, and we have 1 carbon. So we can write it like this. How many carbons do we have? 3. How many hydrogens do we have? 8. And how many oxygens do we have? On the left-hand side, we have 2. Have you guys learned to balance a chemical equation before? Anyone? Do you guys know how to balance a chemical equation?
No.
Okay, so you can learn it today. So this is something new for you, Adrian, and I'm sure for all the other students in the class as well. So what we are trying to do is we want to equalize the number of atoms on the left-hand side to the number of atoms on the right-hand side. And let's see how do we do it. So the first step is that you identify the type of atoms that we have. So we have 3 different types of atoms. We have carbon, we have hydrogen, and we have oxygen. So you write it down like this. Now count the total number of each atom. So we have 3 carbons, 8 hydrogens, and 2 oxygens, right? And on the right-hand side, we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens. So you can see there is a difference between this side and this side. So we want to make it equal, and let's see how do we do it. So you can see that we have, let's start with hydrogens and oxygens, okay? So you encircle, so you have 1 carbon, you have 3 carbons here and you have 1 carbon here. So what will you do to change this carbon from 1 to 3? So you put 3 here, okay? You can write 3 behind this carbon as a coefficient. So what will happen? You will balance the carbon on the left-hand side and right-hand side like this, okay? So to make this side equal to this side, you wrote 3 carbons. Okay, always remember you cannot change the number of atoms here. You cannot write anything here where this 2 is, right? So you can always write something here, here, or here. You cannot write anything in between the molecule, right? H2O, you cannot write H2-3O. This will be wrong. So only these positions you can add numbers. Is it clear? Any confusion, any question? Okay, let's move forward. So now what happened? So when you changed the number of carbons from 1 to 3, the oxygens also changed. So what do we get when we times 3 times 2? What do we get? 6 plus 1, 7. So by changing the number of carbon, so oxygens now have changed. So how will you fix this? Now we have another step. Now we can add 4 here and to balance hydrogens. So how many hydrogens do we have on the left-hand side? 8. So if we add 4 here and we times it with 2, we will get 8 hydrogens on this side. But what happened to the total number of oxygen atoms by adding this 4 here? The total number of oxygens, it has reached to 10. But don't worry, this is simple. So 3 times 2, 6, 1, 7, and this is 4. So 6 plus 4, 10, right? So now our carbons are balanced. Our hydrogens are also balanced. Now we want to change or balance the number of oxygen atoms. So can anyone tell me what should we do with the left-hand side? So this is a very interesting question that I'm asking. What can we do to the left-hand side to make the number of oxygen atoms 10? Yes, Adrian.
We could put a 5 on the O, maybe.
Excellent. Yes, that's very good, right, Adrian? I'm very happy that you got it. So if you put 5 here, so you times it with 2, so the total number of atoms on the left-hand side, they will become of oxygen atoms, they will become 10, right? So now, if we put 5 here, so the oxygens will also be balanced. So this is how, now look here. So on the left-hand side, we have 3 carbons. On the right-hand side, we have 3 carbons. On left-hand side, we have 8 hydrogens. On the right-hand side, we have 8 hydrogens. On the left-hand side, we have 10 oxygens. And on the right-hand side, we have 10 oxygens. So this is a trial and error method, right? So you have to play with it. You may start changing something and it will disturb the other. And then you can start changing that and it will disturb the other. But eventually, after making some changes, you would be able to get both these sides equal, okay? So you can take up any equation for practice and see if you can balance it or not, or then you may ask me in our next class. So now both of these atoms are balanced together. So this was our today's lecture. So we have 1 minute left. If you do not have any questions, so then the class is concluded from my